Afternoon, everyone. Welcome to today's lockdown lunchtime lecture. Today I have the pleasure of introducing Mr. David Khoza, who's the Executive Manager, Applied Geoscience at the Council for Geoscience. Just before I read his bio, a quick thank you to our sponsors, TerraCo, for the month of July for these lockdown lectures. So thank you very much. And just as Craig mentioned earlier, if everyone can just stay on mute and stop videos, we will have a Q&A session at the end where David can answer any questions. Okay, David is a geophysicist. He's worked in the minerals exploration, mining, and geoscience research. After completing university, he joined BHP, the Mineral Exploration Division, where he was conducting geophysical surveys, primarily in Africa. He took a break, then got back into academia to complete his PhD, which focused on understanding the tectonic evolution of the Southern African lithosphere using magnetotelluric data. Following that, he joined Anglo American, the Technical Solutions Department, where he was supporting several business units in mining, greenfields, brownfields exploration, as well as the research efforts within Anglo American. He then joined SPECTREM AIR, primarily focusing on airborne data processing, modeling, interpretation, and research. And he holds a BSc in Geology Physics, BSc Honors in Geophysics, and a PhD in Geophysics, all from WITS. And his specialty is in EM methods. And with that, David, please go ahead. Thank you.
Yeah, thanks, Liso. Can you hear me well?
Yes, we can. Thank you.
Okay. I'll stop at meeting people. So if you can take over that role, that would be good. Good afternoon, everybody. Thanks for your time. I am currently in a town called Kennard, which is about 120 kilometers south of Upington. I'm sitting in what looks like it used to be a very good bar. Has since been closed because of lockdowns. So because I'm in the middle of the Namakwa, if the connection is not working very well, please excuse me for that one. So what I want to show you today is some of the current efforts that we've been putting in trying to understand the geology of South Africa, mapping it at all scales, pretty much from surface all the way down to the mantle lithosphere. And we are doing that primarily to try and understand mineralizing systems and predict where some of these big deposits could be in South Africa. So what we are currently doing at the Council for Geoscience is conducting a lot of surface geological mapping. And these three images here show you the scales that we've been conducting this mapping over the years, from 1 in a million scale to 50,000 scale. And we've sort of chosen to map the geology at a 50,000 scale for the entire country for various reasons. Okay, so this just says that don't quote me on things that I've said today. Just to introduce the Council for Geoscience a little bit, it's one of the national science councils. We currently have about 448 staff, 60% of which are scientists, geologists, geophysicists, hydrogeologists, and the like. And currently we are running on a budget of about 450 odd million that is dedicated to the mapping program. That's some of the facilities that we've got: core library, book library, also have library that we use for a lot of analytical techniques, and 2 aircrafts that are supporting the mapping program. So just to get into the meat of it, as far as the mapping program is concerned, we are mapping obviously largely the onshore, but we also have a mandate to map in the offshore as well. And this map kind of summarizes what I call our mapping jurisdiction. In addition to mapping in the onshore, if you're standing at the beach, draw a straight line that's about 200 nautical miles the ocean, drag that across the border. So that's the red line there, that's called the economic exclusion zone. That's still part of the South African territory. And that's also an area that we are putting a lot of effort in mapping in the marine environment. And what we're also trying to do is to claim these white spots that would be part of the South African territory. And we do that for a number of reasons. But we've tried to characterize and understand what the what we've defined as the economic drivers in essence. So this is to use geoscientific data to increase the mineral resources pipeline for energy security, water security. Marine mapping is really the next frontier in terms of geoscience mapping, and that's where we will be putting a lot of effort in the next couple of years. Things that have to do with community safety. This is understanding several geohazards, subsidence, sinkholes, things like that, and applying geoscientific data to infrastructure development. Of course, as a science council, we have to innovate. So that's a big part of what we're doing. So what I'll be talking to you today is mainly the onshore mapping in South Africa. But I thought it would be good for you to also know that it's a big marine program that is been efforted, and Dr. Haley Khoza is leading that program. So there's various reasons why the marine program is very important. And one of them is this big ocean current here that you see of the East Coast. Our intention is to characterize that current, try and map the geology beneath there so that we can look into putting power generation units in the ocean floor and take advantage of that high-speed current. So for that to happen, we obviously need to map the ocean floor, understand this geology, the structures, and things like that. So this is why the marine environment, in my case, in my view, is the next frontier. But back to where we want to do, we want to map in the offshore. The latest report from the World Bank has identified several minerals as what they call minerals of the future. And these are the lithiums, cobalt, graphite, and a whole bunch of REEs and things like that. And we know that there's a good potential of these in South Africa. We know that there are showings of these deposits. So our effort then is to try and understand and characterize their extent, try and map the geology, put it into tectonic context, and see whether we can develop predictive tools that will allow us to map these critical minerals. So we know why mining is important in South Africa. This nice graphic from the Minerals Council kind of illustrates why we need to still focus on minerals and minerals exploration and try as best as possible to encourage exploration expenditure in South Africa, which is currently at less than 1% of the global exploration, which doesn't really correspond to what we know to be the potential in terms of minerals available. And there's various reasons for that, and one of which is understanding the geology in detail. So what we see in South Africa largely is that we have a lot of good known deposits up north here. This is an area where geology is on the surface. It is the rocks are there, exposed. Geologists can go and do their work, lick them, take them off for analysis. But when you look at the rest of the country, it's undercover, younger sedimentary cover. Geology is, in some places it is exposed, in many places it is not. So the intent then is to map or to prioritize this area that is undercover and see whether we can build proper tectonic and geological models that will help us to predict and understand these mineralizing systems I'm talking about. So this, in our view, is a place where most tier 1 deposits will come from. So what that means is that we need to use techniques that will allow us to map the geology undercover. So the background map here is the 1 in a million geological map. We can download that on the CGS website. It was released in March earlier this year. So where I am in the Northern Cape currently, this is typically what you see, flat, not much in terms of rocks, a lot of sand. So we need to now understand the geology beneath that younger cover and apply techniques that will help us to map those the deposits under there, the geology under there. So our approach then is to map the geology undercover using several techniques, multidisciplinary geoscience data sets. We are using deep sensing geophysical techniques, which I will get to in a minute, and adopting this mineralizing systems concept, which we know to be the key to exploration targeting. So in terms of the mineral systems, as a geological survey, so our work is largely regional, and the information that we collect would be used to understanding and defining in great detail and lead perhaps geologists and exploration companies to a detection stage. So we need to collect as much information as possible in a regional sense and adopt that and use that information to try and guide where mineral exploration companies would be operating, which is largely in this. So what that means is that we need to understand and map the geology at all scales, from the surface all the way down to the mantle lithosphere. And there's good reasons for doing that. We know that for us to be able to predict where these deposits would be, we have to understand the deep structures. We have to understand where the source of these metals would be that are down at depth, how they migrate up into the upper crust, and how they get trapped and preserved. So this is largely the mineralized system concept, which implore us to understand the geology from the surface all the way down to the mantle lithosphere. So this is what we're trying to do, and there's a very good motivation to do that. Alan Jones last talk on Wednesday, I think, presented this slide, which shows the location of Olympic Dam, which is the IOCG deposit, Australia, and shows how underneath that deposit you can see these big structures interpreted to represent fluid or melt pathways that led to the preservation of Olympic Dam and some of these deposits. So this is a magnetotelluric image that shows the resistivity of the rocks, the blue ones being the most resistive, and the sort of the reddish ones being the most conductive. So this is a motivation really to start mapping geology and understanding it from the surface all the way down to the mantle lithosphere. This was an image published by Graham Heinz in 2018. So for my case, then, in the South African context, what are we trying to do? We are trying to do exactly that, to map geology from the surface all the way down to the lithospheric mantle, to understand the cover thicknesses, understand surface processes, map and characterize the basins, crustal structures, and mantle lithospheric structures. And these are the things that will lead us to developing much better predictive tools in terms of minerals exploration. So the first several information data sets that we are collecting, surface geochemistry, electromagnetics, airborne electromagnetics, understanding the cover thicknesses, groundwater hydrochemistry, solid geology, which I will get to in a second, seismics and magnetotelluric data that allows us to understand the crustal architecture and the mantle architecture, isotope mapping, geochronology, and deep down into the mantle lithosphere using steel seismics and magnetotellurics, and using the xenoliths to give us information about the thermal evolution of the lithosphere. So we think that all of this information will lead us to developing better predictive tools in terms of minerals mapping. So what we've decided then to do is start in the Northern Cape. As I mentioned, it's largely undercover and collecting all of these data sets. And there are other reasons for doing that other than minerals exploration. Northern Cape is also one of the driest provinces in South Africa. Of course, the whole of South Africa is pretty dry, but we think that by collecting all of these data sets, we'll be able to characterize groundwater resources and things like that, which you need to do that if there's going to be any mining there. So in terms of geological mapping then, if you take the whole of South Africa, you divide it up into these little square blocks. These are 1 to 50,000 scale blocks. There's close to 2,000 of these blocks for the whole country. And we've started the program of mapping and mapping geology at these scales. This is the Northern Cape. You can see where we have currently, or where we are currently mapping, or where we're planning to map. The yellowish ones are what we have done so far. We are focusing on these other greenish blobs here. And this is where we have reasonable confidence that this would be areas in terms of minerals exploration, areas to be looking at in the near future. We also collect soil geochem data at the same scale. This is every kilometer, guys take a soil sample, and this is the information that has been collected. So every dot there represents a soil sample that has been taken, and the geochemists take this information, take these samples, we analyze them at our laboratory. I think it's about 40 elements that has been analyzed. And for each of these 50,000 scale blobs, we would like to collect data at that scale for the whole country. And it's a critical data set that we need, not just for minerals exploration, but for other things as well, agriculture and things like that. Also collecting airborne electromagnetics. So here we are using this information for multiple purposes, but largely to understand the cover thickness in these areas, understand structures, small scale structures, but also basement geology, topography, and also for water mapping. So this is where we'll be flying later on this year, and we're hoping to infill in some places in the Northern Cape, but the approach is then to collect regional data of airborne electromagnetics for the whole country. So I mentioned magnetotellurics and seismic data. So our plan is to where we're doing a lot of mapping in the Northern Cape, where we're collecting airborne electromagnetics, also collect magnetotelluric and seismic data, the same points. And that information is will be used obviously for mantle and crustal and mantle lithospheric mapping. But over the next couple of years, we're hoping to infill the country. And obviously there are places where we would pay particular attention to, particularly close to some of the known deposits, and we will infill that and collect data at a much closer space so that we can understand the structures beneath them. So in terms of the seismic data, it's largely broadband sort of information, also collected at the same place where you're collecting MT data. So Alan Jones spoke a little bit about magnetotellurics on Wednesday, so we're not going to get into the details of it. But for those who are not there, it's an EM technique, a natural source EM technique, where we try to characterize the resistivity structure of the Earth from a few hundred meters to a couple of 100 kilometers up to the lithosphere, stenosphere boundary. It's a fairly simple technique. You're measuring electric field and magnetic field. You use that information to derive the resistivity structure of the Earth. You can use the technique really for upper crustal studies all the way down to the deep mantle. Now, the reason for making MT our choice of technique is because of the resistivity ranges of the rocks. There's over 10 orders of magnitude in terms of the ranges of resistivity. So that gives us a significant window into mapping all the different kinds of rocks. So it's really a fantastic tool for characterizing rocks from the shield area all the way down to minerals that would be very, very conductive, like your massive sulfide. We have started this a while back. This is the existing regional stations in Namibia, Botswana, and South Africa. These were done over a number of years, led by Alan Jones out in Dublin. And there's over 750 MT stations in this data set. So what we want to do is to collect the same sort of information for the whole country. This is an image that was created by Alan about 2009 or so that showed the location of the diamondiferous kimberlites versus the non-diamondiferous ones. So you can get a pretty good idea where the cratonic structure is and how you can relate the known diamondiferous kimberlites to the cratonic margin. So if you take a profile, MT profile across from the southwest to the northeast, this is what Rob Evans came up with. And already there you can see some of the great or the big structures, the cratonic structures, the Bushveld complex, Limpopo mobile belt. You can track them down all the way down to 120, 130 kilometers with MT. Bushveld is obviously a big granitic complex with a whole bunch of metal elements in there. So those, that's how it appears as conductive. You take another profile across there within the Sumtex data set. This is what it looks like from the north west all the way down to the southeast. You can see the Kapval Craton there, Kais Belt, the Rehoboth, and the Damara Belt there. So you can characterize the regional structures quite nice. I extended that profile into Namibia, and this is where you can see now the expression of the southern Congo Craton that is present from Angola into southern Namibia in the Damara Belt. So this basically gives you an indication of geology all the way from the Proterozoic all the way up to the Arctic. Marion took the Zimbabwe craton, mapped the Zimbabwe craton in Zimbabwe. Zimbabwe craton expressed up to about 200 kilometers there. So in Limpopo, one of the critical motivations for taking the approach that we are taking is that we recognized the presence of regional structures that are related to the presence of some of the kimberlite structures that we are observing. So this profile here, that's the one from the south to the north here. And as you can see, there's a lot of big crustal structures in there, which you are able to see on the magnetotelluric image. And the Bushveld complex is expressed on this profile here. And you can see the same structure, the Sunnyside Malala Chipisa shear zone expressed there. If you project the location of Venetia, you can see that there's some sort of an anomalous response underneath Venetia, which is probably structurally related. And you can take the same profile from here to there. You can see the same shear zone. There's a Martin's Drift kimberlite complex here, which is related, and we think it's related to that shear zone, as you can see here. It's a good motivation for us to start understanding the crustal and mantle lithospheric using magnetotelluric. Here is the three-dimensional view of the same data. We've projected here the Orapa and Martin's Drift kimberlite provinces related to this shear zone there. So another example is, because we recognize the fundamental structures that we need to map. One of which is the Western Cap Fault, which is in the northern. So if we've mapped at least in the upper crust. Same in Namakwa, that's the Namibian, the Botswana, South Africa border there. North is pointing the other direction. You can see
we seem to have lost Dr. Khoza. So if everyone can just stay on the line, please, let's see if we can get back on. Thank you.
I'm not sure where you lost me, Sfiso.
Can you go back to the previous slide, Dr. Khoza? Yeah, just finish that off about the craton, the northern and the western parts.
Sorry about that. Yeah, so that's the Namakwa terrain that we've mapped, that extends into the Northern Cape, pretty much. And we've also done some studies close to the Aggeneys mining camp, and we can see and observe some lithospheric, crustal lithospheric discontinuity underneath those mining camps. And also see the thick Kalahari cover to the north there, which is about 200 meters. There's also some big crustal structures associated with that mining camp there, as you know. So what we want to do then is to characterize the Kalahari cover in great detail. And for that, this is where the airborne electromagnetics is critical. So we're hoping to come up with a cover map for the entire country where we need to see below it. So in terms of the Northern Cape, as I mentioned, we'll collect MT data. So those are the stations that we are collecting currently. Those are the maps, 1 to 50,000 scale maps that we are planning to do, some that we have done. And what we want to do also is collect a whole bunch of geochron data. Now, in terms of geochron, you know, as you can imagine, some of these places are very hard to access. And geochemistry, soil geochemistry. So we need helicopters and things like that that will support the mapping program. That's the current database that we've got in terms of geochron that characterize the ages of the rocks. We are currently in the middle of acquiring LA ICP-MS system that will augment the dating capability within the organization. And our intention is integration. So we would like to integrate all of these data to develop predictive tools for several kinds of deposits. The soil geochem is fundamentally important for that purpose, and integration is key. So we have started in the Northern Cape, where we recognized the paucity of information. We have collected all of this information. We would like to integrate it to a point where we can get we can start highlighting areas where exploration companies can follow on and have them use this information. Now, just an example to show you why mapping at all scales is important. Here is an example in northern KZN, where we're mapping the margin between the Namakwa Natal and the Kapval Craton up here. So this is a highly complex metamorphic area. This is the map, the geological map that was derived by Matthews and Guy Charlesworth in '81 that we are trying to update. It's a very good map with a lot of structural complexities in it. So we have now collected high resolution magnetics data. We've collected high resolution EM data over this Namakwa terrain. And that's the magnetics. I think this is the total derivative magnetics. It looks like, as you can see there, highly complex in terms of structures. That's the ternary image that highlights some of the granitic and metamorphic sequences. Here is the soil geochem. It's 40 elements that was collected a while back. And here is the 1:50,000 scale geological map that has been recently completed by Nigel Hicks in the KZN office. So if you just try to zoom in into the magnetics data, one can see highly complex and highly structurally complex areas. And the granitic sequences and some of the later intrusions are mapped from the ternary map. Just a comparison between a 1 in a million geology and the 50,000 scale geology. So I'm just gonna flip back. You can see the differences. I didn't put any structures here, so just the lithologies. So obviously a lot more complex than we had known before. And that's the soil geochem data. So I just want to show you a couple of profiles that traverse the boundary pretty much between your northern Kapval and the Namakwa, which is this Tugela thrust front. And that's what you can basically see on this image here. That shows cover thickness. It shows the presence of these deep-seated structures. And if you look at the geochemistry information, what we have been able to see is that from the map, from a 50,000 scale mapping, we have characterized these intrusives that we've mapped, and they have a magnetic signature From the airborne electromagnetics, there's clear conductors in there. And from the soil geochem, we can see high nickel and chrome anomalies. So it is only by integrating all of these data sets that you can start highlighting these beautiful areas where they would be excellent for follow-up in terms of drilling. So the integration of all of that information led us to highlighting these areas that would be great for exploration follow-up. One of the most interesting areas for me, in any case, is the Vredefort. And we collected MT data here in the Vredefort as part of the SAMTEX program. And I took this data to try and understand what is the crustal structure beneath the Vredefort. There's been a lot of talk about the extension of the Wits Basin, characterizing it across and along the Vredefort margins. So I wanted to see what the data says about what we see underneath the Vredefort. So that's the dome there, and this is the Magnetotelluric stations. As you can see, there's a one profile goes like that. It takes a 10 to the north, and there's another one at a much larger spacing up there. So I took that data and inverted it, came up with a structure or a resistivity structure like this that shows resistive basement and some conductors up in the surface. So if you zoom into those conductive areas, so here is probably where we are losing the signal a little bit, so I should probably block that off. But what you're seeing is you've got these conductive features in the upper crust, and you've got the resistive basement underneath the Vredefort. So this is the figure from Uwe Reimold's 2014 paper. And if you try to project what we see and observe on his interpretation, you can see these Transvaal, Ventersdorp, and Wits supergroup rocks overlying the basement. This is seemingly what we seem to be seeing here. And the basement that is coming up to the surface, this is this resistive core there. So it's quite interesting that one is able to see this map, these features, and try and correlate them with what is known about the geology. Marcelo Molezi did some seismic interpretation over the same area. This is his model in his thesis, 2017 MSc thesis. So as far as my dream, in terms of the geological mapping of South Africa, I would like to be at a point where I've collected all of these data, we've interpreted it, and we can slice the entire country however way we want, so that we can get the crustal and the mantle lithospheric structure. This is what my dream is for this program. The motivation for doing that is pretty clear. It's not easy, but I think it is well worth the money to start collecting all of these multidisciplinary data sets in a lot more detail. So these are some of the data sets that we've got internally in the CGS. And the intent is to make these available. There is a data catalog that should be on the website in the next couple of weeks that will say what these informations are, where you can get it. And we spend a lot of time trying to QC a lot of this information. Some of it is very old. So we spend a lot of time trying to QC this information and having it to a point where it becomes usable. So hopefully that will be available. I just thought I'd end off with advertisements. There's a couple of advertisements on the CGS website for specialist scientists in economic geology in particular. So if you are keen, please go to the website and there'll be information there. And that's it. That's all I had for you today.
Thank you, Dr. Khoza, for that very interesting presentation and just showing all those data sets that you are integrating. So thank you very much, and doing it from where you are in the Northern Cape there. So thank you, that went very well. Just before I get into the questions, in the meantime, Dr. Khoza, just have a look at the chats there. I'll get into the questions now. And thanks, Reese, for reminding me. I might have said Mr. Khoza when I introduced you. So thank you for that. Before I get into the questions, I'm just going to send a poll. Unfortunately, I couldn't edit this because I assume a lot of the participants are from South Africa, but I'll send it nonetheless. I'll launch the poll. So while we are doing the Q&A, if people can answer that. So the questions, as you can see, the first ones are just with regards to collaboration. So the first one was with Mozambique, and then on the eastern edge, and then Botswana. And yeah, if you can just answer those for now, and then we'll get into the availability. Thanks.
Okay. Yeah, so because I was already connected, so I can't see the earlier questions.
Okay, let me quickly, so there were two. So the first one was from Sue. Any plans for cooperative studies with Mozambique for the eastern edge? And then just the next one to latch on to is to collaborate with Botswana for the northern part, and then with implications for the diamond industry.
Yeah, so the collaboration with Mozambique has started, particularly looking at the graphite mineral characterization, but also the detailed geological mapping. We've been in contact with the survey there on how we can assist in the mapping, particularly close to the South African border. Same with Swaziland. So in the African context, there's an organization called the Organization of African Geological Surveys, and it's really a vehicle to use for country-wide or continent-wide collaboration in terms of geoscience mapping. So we using that vehicle to try and collaborate with a whole bunch of our neighbors to the north.
Great, thank you. And if there are any other verbal questions, just please raise your hand. There is the raise hand function on the participants pane. You can click that, and then we will ask further questions. Going back to the chat, Dr. Khoza, the other ones was just with regards to availability. So whether the generated data sets will be available to companies and public free of charge or pay for the packages. There's a long question from Dale. As to getting the CGS sourcing information from consultants and incorporating that as well.
Yeah, there's been quite a lot of discussions around data being made available. You know, we have not been very good over the years in getting information and making it publicly available. There was no policy guiding how that will work, for example. Obviously, the intent is, this is information collected using state funds. So ideally, this information should be made available. But there was no mechanism internally to make this information available. So, and we've gone through the whole process of trying to work on the quality control of the data, centralizing it, knowing what the CGS actually has. And that has taken a while, but I'm happy to report that the process has been finalized. There is a data catalog now that should be on the website in the next week that will detail what information is available, where you can get it. Most of it is freely, it will be free, not at no cost. For example, the gridded high resolution data that I was showing you, that information would be available there. The students always have had access to information. All they needed to do was just to let the CGS know that they want information. There's some confidentiality issues around it. There's also information that was collected under almost like a commercial contract with the Department of Minerals and Energy Resources. So that information basically belong to them in a way, and it's we've been putting a lot of effort in trying to get that information so it can be made available. But that information is it will still be under some sort of commercial prescripts, if you like, of the contract. But I think eventually it will be made available. But a lot more information will be available at no cost in the next couple of weeks.
All right. Thanks. And then just in terms of commercial. Oh, yeah, sorry.
So I'm just reading the comment on the downhole geophysical data. So it is a good point. We don't have a lot of it. We have a lot of core that has been drilled, and what we have done is to invest on purchasing a hyperspectral scanner, so we can scan all of this core that we have in our core shed in Pretoria, and basically get core from everyone else who has drilled it. And we're hoping that it's quite a large information. One core tray is something like 1.5 gigs or something like that. So it's quite large information that required us to invest a lot of money on infrastructure, on storing it and things like that. But the intent is that that facility will be available to anyone really who wants to use it, and that will contribute to the downhole geophysical data. The program is being funded by the government, National Treasury, and the Department of Minerals Resources and Energy. They are basically funding the program.
All right, thanks. Regina, do you want to unmute yourself and ask rather than me reading the question? He's answered answered the first one, but can you ask your question, Regina Molloy?
Yeah, sure. Thank you, Dr. Khoza. Wonderful to get an update about what the Council for Geoscience are up to. Just as a general comment, it's pretty hard to find out what work programs are in place and what's going on. So this has been great to hear. Is there an opportunity in the future to start, releasing more information or hold meetings or newsletters so parties are aware of what's going on? We do follow the website, but it's not very updated all that often. So yeah, an interface with the general geoscience community from my perspective would be welcome periodically.
Yeah, you're absolutely right. Our website is not the greatest. It's very clunky. It's very hard to find information there. There's been a lot of effort in trying to build a data portal. So pretty much what's similar to what you see, what Geoscience Australia has. You can just zoom in onto a map and see whatever information is available onto there. So we've been instructed to build that portal, and that is the mechanism in which the data will be made available. So you'd be able to basically just zoom into an area and see all the information that is there in terms of reports, spatial data, and things like that. So there'll be the main website, but then there will be a clear link there that will take you to the portal, as we call it, and you'll have to put in your details so that we can track who's using it. So that's the intent, and it will be much cleaner going forward. And I know that it has been quite a mission, even before I joined the CGS, trying to get information was seemingly impossible. But I think we are almost there in trying to build a system that works.
All right, thanks for that. I've shared the poll results to everyone. So 83% of the respondents, as we had guessed, are from South Africa. Then the rest of Africa. I see a lot of ex-colleagues from Botswana on the call, and then 3 people from Europe, 1 from Asia, and 2 from Australia. So thanks again, and thanks, David. We had a sellout over talk today. We had just under 100. Okay, I'll allow a few more questions. Hermanus, your question, please unmute yourself.
Good afternoon, David. I want to compliment you on a very excellent talk. I used to be an employee of the Council for Geoscience. My question is there any plan to visit some of the older 250,000 maps using some of the more modern mapping from 50,000?
Yeah, yes, that's correct. So there's a lot of maps obviously that were created a while back, and part of the exercise of collecting high resolution, particularly geophysical data, is to be able to update those maps and have a 250,000 scale geological map available. There's still a lot of gaps in places, and some of the older maps, if you move from one block to the next, things don't match up very nicely. So geologists have to go out into the field, confirm what they are observing and whether those boundaries are matching up and things like that. So the intent is to then release the map at that scale as we are working with a 50,000 scale map. So there was a lot of mapping that was done a long time ago, very, very good mapping. But when we try to put these things together, we find that there's places where things don't match up with what we know. So we have to basically redo the mapping. But yes, that is the intent, and we're basically basing the mapping program on those products that were done a long time ago.
Thank you.
All right, thanks. There is Dr. Khoza's QR code if you want to connect with him on LinkedIn. So just use a QR scanner app of some sort. I'll take two more questions. George?
Thank you, David, for an excellent talk. Thank you, Sifisa. David, you said you're in Kenya right now. I take it the MT survey is being done. Is it being done with helicopter support, or is it mainly ground-based?
Yeah, so for now it's ground-based. I think in the next couple of months we're reaching areas close to the Botswana border and the Namibian border there, where it's really very hard to get to. So we'll use the helicopter to get some of those places. The soil geochem, for example, has been collected. Some of it was collected using helicopter support. It's an expensive exercise, but probably well worth it. If you consider the amount of money anyway that you're putting into the program. So yeah, there's a lot of helicopter support for the soil geochem and also will be for the MT.
Thank you very much.
Thanks, George.
All right, thanks, George. Dr. Khoza, just a question from Marcy. He had asked this question after your talk at GeoSkills last week, and maybe that's the reason you're in the Northern Cape. But he's saying, is there any benefit to set up an office strategically in Kimberley for like the Northern Cape and Free State specifically, because Northern Cape is so huge?
Yeah, we've got an office in Uppington, so that's basically our base for the Northern Cape operations, and it works very well. I mean, it's a small office, but it caters for what we need to do in any case. Most of our scientists are based in Pretoria, but the Northern Cape in the next couple of years will be probably our most active office, given that this is our focus area for now.
All right, thanks. Okay, I'll take the last three hands that are up. Celias.
Thank you for your talk, Dr. Khoza. I just want to know, will there be any opportunities for geology graduates to get involved with this mapping?
It's a good question. We certainly I don't believe that we have enough people to carry out this scale of work. And that provides sort of opportunities for young graduates to come in and learn. Our intent is to use this program as a launch pad really for young scientists. In my view, there's no better place to learn geosciences under CGS. It is part of what the organization needs to do. You're exposed to a whole bunch of data sets, working in a variety of geologic settings. So there's a lot of focus on getting interns on some sort of a contract basis to come and contribute to the program. The geochronology data that I was showing was developed by 2 interns who came in for, I think, 6 months, and they scoured through the literature and developed a database. It's an extremely important database that we have neglected for a very long time that we're trying to build up. And that was done by 2 interns, and they did the interpretation, the QC, and all of that. So there's incredible opportunities to learn in the CGS, but for now it's been done, you know, via internships, if you like. So, you know, keep looking at the CGS website as and when they come.
Thank you, Doctor.
All right. Reese and KB have disappeared. They had questions, but they probably maybe also jumping off to the Geological Society talk, which is happening in the next 3 minutes, which I'll mention shortly. Okay, KB, there you are. Go for it.
Thank you, Sifiso. Thank you, Dr. Khoza, for that insight presentation. Mine is not a question as such, it's more of a comment. Coming from an old age background, I think this data collection is very important. However, we need to accelerate the geological mapping ahead of any other technique so that you can give other techniques the right orientation of data collection. So because if you go ahead of the geological mapping, you find that sometimes your orientation of other techniques takes the wrong direction. So as such, makes a bit complicated for the interpretation of the data, especially in a very complex environment. Thank you.
Yeah, I mean, you know, my approach is not either or. It's an integrated mapping program in places where there are no rocks. We would naturally do things like geophysics. But the intent is not just to collect one data over the other or prioritize one technique over the other. We adopt an integrated approach where every 50,000 scale block must have all of this information that we need. Obviously, you know, some places there's no point in collecting soil geochem, for example, if there's 200 meters of cover. But certainly, you know, the intent is integration, multidisciplinary integration of all the geoscience data. In some cases, geophysics will guide geology where they should map. In some cases, will be guided. The geologist will guide where the geophysics needs to be done. It just depends on where you are and the complexity of the geology. Yeah. So, but by and large, we try to integrate as much as possible. So in the planning phase, the geophysicists don't sit together and plan. We all sit together around the table and develop a mapping approach.
All right. Thanks, David. Thanks, KB. I'm also going to go to a 2 p.m. meeting shortly. So just in closing, thanks again to David, and thank you to all the participants. Just a reminder that actually in a minute's time, the Geological Society of Zimbabwe are having a talk on EM, airborne systems, and EM, mineral exploration on the Yako Mainspan nickel copper deposit. That's happening now. If you've got our Google Calendar for the lockdown lectures, you can access that. And going to Monday, we've got Tebogo Makubelo's on this call. He's going to be talking on the role of cosmogenic nuclides in determining recent surface changes and processes in Southern Africa. That's on Monday, so please do join us for that. And before I close, thank you again to our sponsors for the month, TerraCore. And please, everyone, keep safe and enjoy your weekends, and we will chat soon.
Yes, everybody, thank you very much for tuning in. Have a
Cheers.
good one.
Thanks, Dr. Khoza. Ciao. I'm going to close the meeting, Craig.
I'll close it from this end, Sifiso.
Okay, I got to jump off to a 2 p.m. Ciao.
Cheers. Good afternoon, everyone. Please have a nice, safe weekend. Thank you very much for joining us.